a website from the early 2000s. It was often a chaotic, cluttered mess of varying fonts and broken layouts. Now, look at a modern interface, clean, responsive, and legible on any screen. To understand why early pages were so fragile, you have to look at the code. Early developers had to rely on endless, identical block elements called divs. A div is just an empty container. It told the browser nothing about what was actually inside it, leading to a sprawling, unreadable structure. Because the browser couldn't understand complex media, developers forced motion onto these pages using heavy, vulnerable third-party plugins like Adobe Flash. That changed with the widespread adoption of HTML5 and CSS3. These standardized languages brought robust styling and multimedia support directly into the browser itself. Modern web development abandoned those early visual workarounds. Today, it relies on a natively understood semantic architecture to create reliable, consistent experiences. This brings us to the concept of the semantic web. Instead of just laying out a page visually, semantic code gives the content actual meaning. This diagram shows how HTML5 semantic tags function. By assigning specific tags like header, article, and footer to sections of a page, developers create a precise map. Search engines read this map to understand the content, and screen readers use it to help visually impaired users navigate. HTML5 also introduced specialized interactive tags. A dialog tag creates a functional pop-up natively, requiring zero external JavaScript. Using semantic HTML5 transforms a flat visual layout into a functional, readable map for both human users and machines. For multimedia, HTML5 introduced the canvas element, eliminating the need for vulnerable plugins like Flash. This video illustrates how the canvas acts as a dedicated rectangular space on the page. Using a built-in application programming interface, or API, developers can draw complex, dynamic vector shapes that render instantly inside the browser. Rendering graphics natively removes the massive security vulnerabilities associated with third-party plugins, and it significantly reduces page load times. Removing those external dependencies made navigating the web faster, safer, and much more stable for the end user. To see native styling work, consider a raw, unstyled HTML submit button. It's functional, but flat. This image demonstrates how CSS3, cascading style sheets, can natively render complex visual effects that used to require static image files. Notice the 3D shadow effect applied directly to the text. We can physically alter the button shape using the CSS3 border radius property, which takes those sharp right angles and rounds them off. Applying a linear gradient gives the flat, two-dimensional button the illusion of depth and texture by shading it from top to bottom. To make the button react, we add an event listener. This acts as a trigger that tracks when a user's mouse cursor hovers over the specific element. The moment the cursor enters the button's boundary, the hover state applies a blue outer box shadow and a darkened inner inset shadow. If those shadows blinked on instantly, it would look jarring. The CSS transition property governs the timing, forcing the shadow effect to bloom and fade smoothly over half a second. Combining these native CSS3 features creates a tactile, satisfying user experience out of a simple data point, completely free of external graphics. Zooming out from that single button, we can see how these rules apply to a fully realized, lightweight modern web page. This animation shows CSS3 media queries in action. Media queries detect the user's specific screen size and constraints in real time, allowing the layout components to fluidly stack and rearrange as the window shrinks from desktop width to mobile width. The exact same underlying HTML code delivers both the desktop and the mobile experiences. The core header and article tags remain structurally identical, while the CSS changes the presentation. HTML5 and CSS3 moved web development away from a patchwork of brittle visual tricks into a standardized, inclusive system. By mastering semantic architecture and native styling, developers engineer digital experiences that are fast, accessible, and ready for any device.